Hello everyone! Today I would like to give you a lesson on the topic trapezoid. Before starting to watch this video, don't forget to subscribe to my channel and like it. I will be very grateful to you for that. Today we will start our geometry lesson with a shape that is often seen not only in textbooks but also in the real world, a trapezoid. If you look at the Hoover Dam in the USA from the side, you can see that its shape is very similar to a trapezoid. Engineers chose this shape so that the structure would be stable and withstand the enormous pressure of water. Geometry helps to understand why such objects look the way they do and how to design them correctly. A trapezoid is a quadrilateral in which two sides are parallel and the other two sides are not parallel. Here are these interesting trapezoids in front of you. Let's carefully look at the properties of a trapezoid. 1. The two sides of a trapezoid are parallel to each other and are called the bases, but not parallel sides are called the lateral sides. 2. The sum of the angles lying on one side is 180 degrees. Angle A plus angle B equals 180 degrees. 3. The midline of the trapezoid, connecting the midpoints of the sides, is parallel to the bases and is equal to half their sum. Let's prove that the midline is equal to half the sum of the bases of the trapezoid. So we take such a trapezoid ABCD. We mark on it that AT equals TC, TF equals M, EF equals N, AD equals B, BC equals A. And we also need to prove that the midline is equal to A plus B divided by 2. And so we take the triangle ABC. In it, the midline N, which is equal to half the base of this triangle, N equals A divided by 2. Then, in the triangle ACD, we do the same. We find the midline, which is equal to B divided by 2. And these segments N and M, if we add them, then they form the midline of this trapezoid. So we add them and we have that the sum of M and N equals A plus B divided by 2, is what we were asked to prove. Most of the time, we find the area of a trapezoid using this formula, which means that in order to define the area of the trapezoid, we must multiply half the sum of the bases by the height. So S equals A plus B divided by 2 times H, where A and B are based and H is height. Or we can simplify this formula and it will be like S equals M times H, where M is half the sum of bases. Now let's prove why we calculate the area of a trapezoid using this formula. Well, let's take the triangle ABD. We know that we can find the area of a triangle using the formula half the product of the height by the side to which it is adjacent. So the area of the triangle ABD is 1/2 B times H. The area of the triangle BCD is half the product of A by H. Then we know that the sum of the areas of these triangles forms the area of the trapezoid of ABCD. Therefore, we add these two areas, and after we take H divided by 2 out of the brackets, we get what we were asked for. The formula is proven. What types of trapezoids exist? Let's find out. Types of trapezoids. 1. Isosceles trapezoid. The lateral sides of this trapezoid are equal. The angles adjacent to the larger base are equal to each other. 2. Right angle trapezoid. One of the sides of the trapezoid is perpendicular to the bases. It has 2 right angles. 3. General or arbitrary trapezoid. This is a quadrilateral that has at least one pair of parallel sides, called the bases. The other 2 sides are not parallel. Problem 1. Determine the unknown quantities using the given data. And so we see that here we need to find the midline of this trapezoid. So we already know what the midline is, and here is the formula in front of us, so we boldly find it. X equals 13 plus 17 divided by 2. Hence X is 15. The answer is 15. This is the case where we are given the middle line. We are asked to find the larger base, so we make this very equation, and hence 8 times 2 equals 16. 16 is equal to x plus 6.5, so hence 16 minus 6.5 equals 9.5. The answer is 9.5. Problem 2. Determine the area of the trapezoid using the given data. And so on the form given, everything necessary to find the area of the trapezoid is given to us, so we boldly find it. S equals 2 plus 5 divided by 2 times 10. The area of the trapezoid is 35, so the answer is 35. Now let's look at the second trapezoid. We see that the midline, which is highlighted in green, is already given to us, so we just have to substitute 12 instead of this half sum. After the substitution, we have that the area of the trapezoid is 12 times 15, which is 180. The answer is 180. Problem 3. The figure shows us a right-angled trapezoid ABCD. BC equals 8, AD equals 10, and angle BAD equals alpha. Determine the area of trapezoid ABCD. Well, what do we solve first? Let's draw the height BH, and we have a rectangle BCDH. If HD is equal to 8, AD is equal to 10. So from here, AH equals 10 minus 8 equals 2. And I have already marked in this figure that AH equals 2. And now we must remember that the tangent of an acute angle is equal to the ratio of the opposite leg to the adjacent one. From the right triangle ABH, we have that BH divided by 2 equals tangent of alpha. BH equals 2 tangent of alpha. Let's remember the formula for finding the area of a trapezoid, and it is equal to half the sum of the bases multiplied by the height. Substituting the bases and the height, we have that the area of this rectangular trapezoid is equal to 18 tangent of alpha. This will be our answer. So, if you understood everything today, I would give you Arch KRGT1 as a gift. If you are worried or excited because you did not understand something, no problem. Watch this video again slowly. Never give up, and I wish you to understand it as soon as possible. Bye.